know if 3 is going to be enough to do this with, but let's hope. And that is it for the gameplay. So, where shall we start? Let's start with our coins. So what our coins are going to do is they are going to... Actually, let's start with the 4 principles of object-oriented programming. Our first principle with that is going to be abstraction. So inside of our coin, we have the collectible component, and this is one way that we do abstraction by, or we utilize abstraction by hiding our implementations inside of other objects. So our components allow us to abstract information out of them. Next, we will talk about encapsulation, and that has to do with our functions. So our coins functions and our jump pickup functions are inside of our collectible functions, but our collectible function, or our coin is only using what we need for the coin collectible, but not using what we need for the pickup collectible. Inheritance. Let's talk about that. So here inside of our blueprint folder, we have our health component, but we also have our, must be in here, player health right there. So our player health inherits from our health component, which makes it easier for us to do things like manipulate our. So basically, when this runs, it's going to run everything that the parent would run, and then it prints to screen these messages. And all these messages are the player health. This was a preliminary addition that I made specifically to print this to screen during development. But what it's going to do, because it's grabbing from our parent, is it's going to do everything that our parent health or that our health would do on tick. And it's going to do everything that our health does on begin play. It's going to have the same delta seconds, which is or how long it takes to draw a frame, which means that if we multiply how long it takes to draw a frame, or if we take how long it takes to draw our frame and multiply it by our on-screen duration, then we can manipulate the length of this. However, this is not where I want to talk about delta seconds. And then we have multiple different pickups. We have our health pickup and we have our not our health pickup. We have our jump pickup and we have our coins. Those are both different types of collectibles, but they are not the same type of collectible. And that is how we can have polymorphism. They are both collectibles, but they are not the same collectible. Next, we're going to talk about some movement and math, and I'm going to pull this up to talk about that, and this will also help us talk about inheritance, because our actual objects that spawn in the world are inherited from this object, which was our prototype. So within our object, this object does a lot of math. There's a lot of thinking. So we have our variables. Variables are basically placeholders where we can store a tidbit of information to be used for a later piece of code. For example, we have this damage here. This damage gets set here. It gets set here. This one is taking the current damage times 25. This one is just setting the damage to 25. And then we use that damage to take damage. And our damage will be 25. And if our damage is if can be damaged is set to false, then we're going to basically set our damage to a quarter of 50 and add our points to add 1 to our points. And if it is, or if you can be damaged, then we're going to set it to 25 and 25 points, and then we're going to spawn the explosion actor at the location of our object and destroy our actor and take damage. Now let's talk about movement and vector math. So here inside of our get normalized direction between player and target function, you can see that I have get actor eyes viewport and get actor location. These are going to give us our direction, or where our actor eyes are, and then this is going to give us where our spawner is, or the owner, or not the spawner, the object itself is, and it's going to subtract where it is from where the target is, and then we're going to normalize, which is going to allow taking our this normalize and multiplying it by our delta seconds, which we are importing or inputting, and then multiplying that by our speed allows us to move at 1 frame per second. Or no, this allows us to move. It allows us to move smoothly at every time a frame is drawn. Then I'm also taking that and adding this normalized difference to where our current actor is, and finding our lookout rotation between our actor self and the actor that we want to look at. Now we're going to go to our tablet. So here in tablet tablet 02, we have our load levels. So this particular load level is going to run next level, which has an array of levels that it will cycle through as we run the next level function. And that will increase our level number based on every time we finish a level. So basically, every time you finish a level, the level number increases, and then when you come back to the tablet, you're able to go to the next level. For collision and overlap events, we will go with the, we'll go with the deer. So, on event, on component begin overlap of the interaction, which is our sphere, it is going to set visibility of the widget, which you can't see. That is the widget that pops up, and is going to set the visibility of that to true on an overlap if the player is overlapping, and only if the player is overlapping. On event begin play, we're going to grab the starting intensities and store it in a variable, and then we're going to set the intensity to 0. And on our where did I put there? Okay. So now let's open the gem spawn trigger to talk about further overlaps. So that didn't help. basically open the wrong object. Okay, so let's talk about this. So in this function, we are checking to see if all the deers are glowing, and if they are, or if a deer is glowing, then it's going to add 1 to this this local variable. If this local variable is equal to the length of the amount of statues I have, then it's going to set all glowing. And if all are glowing, then all the deers are lit. If all the deers are lit, then we are going to grab the nearest spawner, and we are going to spawn seeker. And that happens on event begin overlap. And that is when it overlaps with this cube, which is a trigger event. Now, we also have input actions. So, let's go back to the deer. And it's actually not in the deer, it's in actual, or it's in the actual third person. So here on a P, we are going to grab our nearest glowing statue and make it glow. If our inside of our get glowing statue, we have, which is a custom function, we are going to get our statues, which is created right here. We're going to get my statues, which is all of the deers on the level. We are going to get our distance to the first deer in the order, and we're going to set that as the nearest distance. Then we're going to go through each and every one of the deer in the list, and we are going to get the nearest distance, or get the distance between it and the nearest distance. If it's less than or equal to the nearest distance, then we're going to set it as the nearest object in the variable, and then we're going to get the distance between this target and the nearest one, and we're going to set the distance. Then, once we have gone through each and every one of them, we are going to return the nearest one. Now we can cover the unit. Let's cover the shop. So this is our shop. So here we have our on mouse button down. So on click, we are going to see if the player has 50 points or 50 coins, and if they do, we're going to subtract the upgrade value, which is the value of the upgrade that they want, from their total points, and then we're going to set that as their points. This is our upgrade value if it is true. And then we're going to do our jump pickup custom function, which is going to upgrade our jump by upgrading or grabbing our max jump and grabbing our upgrades, or setting our upgrades +1 and grabbing our max jump count and adding that +1 or plus our upgrades, and then setting the max jump count. We also have our a custom event is our upgrade, and that is going to do the same thing as the it's going to do some. Yeah, jump pickup is here. Yes. Now, back to user interface. Graph. On mouse button down 0. Yes, so on mouse button down 0, we're going to remove the shop from the viewport. Then we're going to create health bar. We're going to add, our health bar is the original UI. Once you enter the game, or after hitting play, and then we're going to add that to the viewport. Then we're going to set our input to game mode only and cast that, or cast our player pawn to actual third person. And we're going to grab our current and max health and update our health bar. So now we have our physics actors. So on explode, we are going to come back here. So we're going to get the owner of this exploder component. We are going to spawn an actor on where this was, and we're going to spawn the explosion effect so that it looks like it explode. Then we are going to get our location. We're going to save that as a variable, and we are going to get all of the actors that it overlaps within a sphere radius, or within a sphere. And we're going to set all of those actors as actors to push. Then for each actor in that array, we are going to first grab the static mesh component and set physics to simulate. Then we're going to get our vector away from source, which is a custom event where we see where the actor is, or where the target actor is and where the current actor is, and subtract that from each other and return the difference. Then it's going to get force by distance, which is going to grab ourselves and the target that we wanted, that it's looking at, to apply damage. And we're going to divide the distance between, or the distance between the two targets by the radius of our explosion. And that's going to return us with a percentage of the radius. And if we take that percentage of the radius and subtract it from 1, which is equal to the maximum amount of the radius, then multiply it by our force, we are able to deal force based on the distance from the center of the explosion instead of from the outside of the explosion. Anyways, this has been my final project, and I hope you enjoyed. Now to cover the boards page. So, this is my boards page, and here in our portfolio, we can see that I have our files listed here so that I can distribute them easily and also allow others to play the game.